Hello and welcome to the Water Hardness Lab. For this lab, we're going to test the hardness of our Georgia water here. So to do that, you will use a variety of materials and chemicals to help us. So first off, we're going to start off with our volumetric pipette. We'll notice that this one is a little bit larger, so it can measure 25 milliliters. We also have our indicator bichrome black and our ammonium chloride buffer. Now our main reagents are going to be calcium chloride and EDTA, our acid and our base in this specific reaction. We'll use a variety of measuring tools, including graduated cylinders, to measure out all of the volumes here. So to start off, I'm going to add a little bit of EDTA to our burette here. What that does, and then I'm going to go ahead and wash it. Now what that does is it coats the inside of this burette with a little bit of our EDTA solution, ensuring that any other chemicals that are there are kind of washed away. This also prepares the burette for our full EDTA solution and reduces the chance of contamination. Now that I've washed that burette, I can go ahead and start to add the majority of our EDTA solution to the burette itself. Now the burette holds a maximum of about 50 milliliters of fluid, so I'm going to try to utilize the most of it while keeping inside the graduations. This allows me to measure the initial and final volumes whenever I'm doing the titration during the experiment. There you can see my initial volume. Now I will go ahead and prepare the solution I'm going to titrate into. So to start off, we're going to have a ammonium chloride buffer. What this solution does is ensure the basicity or the high pH of our starting solution. So we'll take about 10 milliliters of that and add that to our larger graduated cylinder. So this large graduated cylinder is great because it allows us to take that 10 milliliters and then add something else. What we're going to add is about 65 milliliters of deionized water. Now in this lab, there is a big difference between the deionized and the non-deionized water we use, because we're going to be using regular Georgia tap water in the second part to measure its hardness. Here we just use deionized water, which has no ions in it, just H2O, to get a dilution of our buffer. So you can see that we have about 75 milliliters total of our buffer and our DI water right now. We'll go ahead and add that to the Erlenmeyer flask. And to that, we'll add some of our standardized calcium solution. So this standardized calcium solution has a known concentration of calcium. We'll use this to help us figure out the unknown concentration of the EDTA solution. So we'll add all 25 milliliters to our Erlenmeyer flask here. And we'll go ahead and add about 10 drops of our indicator. So this indicator will change its color when our pH changes to the neutralization point. So you see it starts off as a nice dark purplish color. And as the pH changes, that purplish color will become a more blue or cyan color. So we'll go ahead and put that in front of this white backdrop so we can see the color change a little bit more clearly. And I'll go ahead and start dripping down the titrant so we can start the titration. Now, during the titration, of course, I swirl to keep the solutions homogenized. All right, so you see there, we now have turned that purple solution into a bluer solution. It's a little bit more difficult to see, but the color change is definitely there. Now we can see our final volume here. So our volume delivered of EDTA is, of course, our initial minus our final volume, or the difference between the two. Now the data for the other trials will be given in the data sheet here. Now we'll start again. I've filled up this EDTA, or I filled up the burette with EDTA solution to start up part 2, in which we're going to go ahead and test the hardness of our Georgia tap water. So now that we know the concentration, or we've calculated the concentration of our EDTA, I'll just go over here and open up our tap and fill up about 50 milliliters of our water into this graduated cylinder after washing it a few times first. So you see about 50 milliliters of our tap water. So this tap water will have some calcium ions in it, and that calcium should react with our EDTA to produce the same color change that we witnessed last time. Now we're still going to go ahead and add our buffer solution so we can actually witness the color change when the buffer stops interacting with the calcium ions in the water, and then the EDTA starts interacting with it. So to see the color change, of course, we'll need to add some of our indicator here. Just like before, it'll start off as a purplish color, and when the neutralization point is reached, then it should go to a blue or cyan. All right, we will make sure it's homogenized and then start our titration. Of course, swirling constantly. And wow, that was very quick. So as you see, it turned a nice blue color whenever the neutralization point was reached. We just used a few milliliters of EDTA, which means our water here in Georgia is not very hard. There you go. You can see the final volume there. So as you see, we discovered that we have soft water, and we can do 2 more trials, as you see in the data sheet, for the data over there. All right, thank you for watching.